हेलो हेलो हेलो
हाँ हेलो Can you hear me?
Yes, ma'am.
यस मैम
Okay.
हेलो হ্যাঁ আমি অনলাইনে ক্লাস করতে
Okay, I will start the class. Today we are going to discuss about the DC choppers. So, actually what is DC choppers? In case of AC, the function of transformer is that to step up or step down the AC voltage. Similarly, in case of DC circuit, the DC choppers are required to convert a fixed voltage DC source into a variable voltage DC source. And is directly converts DC to DC, okay? And what are the application of DC choppers? It is used in traction motor control in electric automobiles, trolley cars, marine hoist, forklift trucks, mine haulers, regenerative braking of DC motor to return energy back into the supply, DC voltage regulators. And why we use the DC choppers? Because the advantages are smooth acceleration control, high efficiency, fast dynamic response, and also the regeneration. Then we are directly go to the principle. In case of AC, there are step up and step down transformer. In case of choppers, there are also step down and step up choppers. Okay. Please mute the voice.
ম্যাম কিছুই শোনা যাচ্ছে না।
শোনা যাচ্ছে না?
না না,
একদমই শোনা যাচ্ছে না।
ম্যাক্সিমামটা ল্যাগ করে যাচ্ছে, বাফারিং হচ্ছে প্রচুর পরিমাণে। হ্যালো,
Wait. Hello.
হ্যাঁ ম্যাম বলুন।
হ্যালো,
Can you hear me?
হ্যাঁ ম্যাম শুনতে পাচ্ছি, বলুন।
This is the basic circuit of chopper, step down chopper. Okay. Here we use a
Okay.
switch and a resistive load, and we apply a supply voltage Vs, and the current is flowing when the switch is in on condition. The current is flowing through the load is IO, and the output across the R is VO. And the switch which is used as chopper, it may be any of the semiconductor switches like power BJT, power MOSFET, GTO, or force communicates thyristor. Okay. Now, when the switch is in on condition, then the time is, for the time being, T1, Vs is applied across the R. So the value of output voltage VO is same as Vs during this position. Means that during this time T1, and when the switch, means the chopper is open, then there is no current flowing through the resistor, so there is no voltage drop, means it falls to 0. Okay.
Okay.
This T1 is also called the turn on time T1 or T on, and T2 is called the turn off time. And this is the waveform of the output voltage, and this is the waveform of output current. This is not I, this is I naught. It is nothing but Vs by R, means the shape of the waveform are same, but the magnitude is less than by a factor 1 by R. So now we have to calculate the average output voltage. This is nothing but Va is equal to 1 by T integration 0 to T1, actually 0 to total capital T, but as from this position to this position, the value is of V naught is 0. That's why we integrate over 0 to small t1 or t on, V naught Vt. From here we get the value T1 by capital T Vs. This T1 by capital T is also represented by K, and this K is known as the duty cycle. In case of chopper, duty cycle is very much important term. Okay.
Hello.
And from here, we know that F is equals to 1 by T. That's why it is written that it is also F T1 Vs. And what is F? F is a chopping frequency, and capital T is a chopping time period. Okay. Then what is the RMS value? RMS value is nothing but under root of 1 by T integration 0 to, actually this is T1. Okay. For our simplicity, we use here KT, means K into T means
হ্যালো,
hello,
হ্যাঁ ম্যাম বলুন।
শোনা যাচ্ছে?
হ্যাঁ ম্যাম শোনা যাচ্ছে।
K means T1 by T into T. That means it cancel out, this integrates between 0 to small t1. Okay.
Okay.
For our simplicity, we use KT.
Hello.
Hello. So after calculation, we get that V naught is equal to under root of K into Vs. Okay. Here we consider that the chopper is a lossless chopper, means there is no loss between the input power and the output power. Means the input power and the output power is same. So what is the value of the Pi is nothing but 1 by T integration 0 to Kt d naught I dt. From here we get the value of Pi is nothing but K v square by R. Then what is the value of effective input resistance? Effective input resistance Ri is equal to Vs by Ia. And we get the value of Ia is nothing but K into Vs by R. So from here we get that the effective input resistance Ri is nothing but capital R by K. Okay. Okay. Then depending upon the duty cycle K, if we vary the duty cycle K from 0 to 1, then how we vary the duty cycle? We vary the duty cycle from 0 to 1 by varying the turn on time or the total chopping time period or the frequency. Therefore, the output voltage VO can be varied from 0 to Vs by controlling the value of duty cycle, and the power flow also be controlled. Okay. This can be done by either constant frequency operation. This is also called the pulse width modulation, and another is variable frequency operation. We discussed these two topics in the class in details. Okay. Then step down chopper with RLE load means here we use the load as R, L and E, and here we also use a freewheeling diode. So in case of mode 1, what is the circuit in mode 1? This is the circuit means the switch is when the switch is on, when the freewheeling diode does not work and the current flows through the inductance, resistance and the load EMF. And this is the same as the voltage diagram from the previous one. But the current, as there is presence of inductance, in case of on time, the current is increasing and during the off time, the current is decreasing. Means this is for mode 1 and this is for mode 2. What is mode 2? In case of mode 2, the switch is in off condition. That means the current flows through the freewheeling diode. Okay, and then the inductive current is decreasing during the time 1 minus K into T. And from mode 1, this is the equation of Vs is nothing but R I1 plus L di1 dt plus T. From here we get the solution I1T. So this is the I1 solution of I1T. If we solve this differential equation, then we got the equation of I1T, which is nothing but capital I1 e to the power minus T R.
ম্যাম এই জায়গাটা একটু রিপিট করবেন?
কোনটা?
স্টেপ ডাউন চপার উইথ আরএলই লোড, ওই জায়গাটা একটু বুঝতে পারলাম।
This is the main diagram of step down chopper with RLE load. Okay. So in case of mode 1 means when we is in on condition, means this is closed. Okay. Then the current is flowing through this path. There is no current flow because we know that the diode is an unidirectional device. Okay. So in case of mode 1, we can redraw this circuit.
Yes.
Okay.
Okay.
So from here we get the output voltage is same during time T on means the on time, the output voltage is same as the supply voltage, and during the off time, during the off time, the output voltage becomes zero because the switch is open. When the switch is open, there is no voltage drop. Am I clear?
Clear.
Hello.
Hello.
Clear.
So, in this case, as there is inductive load, from the equation of voltage Vs equals to R I1 plus L di1 dt plus capital E. This is a differential equation, first order differential equation. So after solving this, we get the value of current I1t is this. Okay. And if we draw this, so we see that there is an increasing increasing current during the time period T on. Okay.
Okay, ma'am.
So next, in mode 2, that means when the switch is open. As switch is open, there is no voltage. Means this supply voltage does not work here. There is a current flow through the freewheeling diode because there is a voltage drop across the low L, which is L into didt, and also for the back EMF E. Okay. So in this case, the nature of the current through the freewheeling diode is decreasing during the time period T off or T2. So this is the load current of mode 2 can be found out. There we take it 0 as there is no supply voltage. Okay, and 0 equals to R I2 plus L di2 di2 dt plus capital E. Okay, and we consider the initial current small I2 is nothing as capital I2, and then we get the value of I2 is nothing but this. Okay.
Hello.
Hello. Hello.
কথা আসছে না ম্যাম।
ম্যাম ডিসকানেক্ট হয়ে যাচ্ছে ম্যাম।
ম্যাম শোনা
শুনতে
যাচ্ছে?
পাচ্ছি না।
শুনতে খুব প্রবলেম হচ্ছে ম্যাম।
নেটওয়ার্কের প্রবলেম।
সবাই একটু মিউট করে রাখতে হবে যে টাইমে ম্যাম কথা বলছে।
তোমাদের যখন কথা বলা হবে তোমরা তখন অন করবে, ঠিক আছে? আদারওয়াইজ তোমরা সিস্টেমটাকে মিউট রাখো।
তাহলে ভালো করে শুনতে হবে।
This I2 minus I1, which is denoted as del I, and this is known as peak to peak ripple current. Okay, and this is peak to peak ripple current, and this is given by this equation. So what are the maximum conditions? We know that for finding out the maximum condition, the derivative must be 0. So here we use d del I dk is equals to 0, and from here we get the value of duty cycle is 0.5. So for the duty cycle k equals to 0.5, we get the maximum value of ripple current. Okay, this is also important for MCQ question.
Okay.
And these are the derivations. And next we go for the principle of step up chopper. Okay. So this is the basic arrangement of step up chopper, which consists of a inductance, a diode, and a load. Here we draw a dotted capacitor load. This is discussed after. Okay. So this is none of our business right now. So this is the main circuit and this is the switch. Okay. So what is the mode 1? The mode 1 is when the switch is in off condition. When is off condition, then the current is flowing through the diode, means the diode becomes short circuit, and here we use a load. So this is the first circuit. Okay, clear?
Okay, ma'am.
Clear, ma'am.
And for this the
শোনাই যাচ্ছে না কিছু।
মিউট করে রাখ, মিউট করে রাখ।
তুই ভাই মিউট কর, তোকে তো বারবার বলছি মিউটটা কর, মেসেজ পাঠালাম তো।
মিউট করা আছে তো।
আরে বাকি যারা আছে তারাও
মিউট করা থাকলেও প্রবলেম হচ্ছে।
অনলাইন একটু তো হবেই, কিছু করার নেই।
প্রবলেম আছে, কিছু করার নেই।
নেট স্লো বলে, বুঝলি, একটু নেট স্লো আছে সবার, তাই ওতে কিছু হবে।
অনলাইনে একটু প্রবলেম হবে, কিছু করার নেই।
হ্যাঁ।
So this is the in mode 1, if we consider the current is flowing I1, okay, so this is the waveform of I1, and when the switch is off, when the switch is in on condition, then the current is flowing through this. So this is the value of I2 and this is I daylight. Okay, so now we go to the equation. Here, when CH is on, the voltage across inductor what is? GL is nothing but L di dt. Clear? And what is the difference? This di, this di is represented at del I, means peak to peak ripple. When dl becomes ds by L into T1, means during the on time. Okay. Then what is the value of instantaneous output voltage? It is nothing but VO is equals to capital VS plus L del I by T2. Then we put the value of del I here. We get a value equals to Vs into del I by 1 minus K. And depending upon the value of K, or we regulating the value of K, we vary the output voltage. Okay. Now, if we applying a capacitor, large value of capacitor in case of load, means a capacitor is connected as a load, then the output voltage will continuous and the output voltage becomes the average value of VA. Okay. And here we see that this is a step up because here VO is a function of VS into some factor. And after varying the value of k, we get that VO is greater than VS, because if we put any value of k, if we put k equals to 1, then VO becomes infinite. Am I right?
আরেকবার বলুন এখানটা।
If we put the maximum value of k is equals to 1, means the value of duty cycle becomes, maximum value of duty cycle becomes 1, because the value of duty cycle varies from 0 to 1. So maximum value of duty cycle is 1. If we
Yes.
put k equals to 0, then V naught is equals to, put k is equals to 0, then V naught is nothing but Vs into k. Here we also see that VO is greater than Vs. Clear?
Clear.
And if we put the maximum value of k, that means k is equals to 1, then VO becomes infinite. Vs by 0, this is infinite. From the graph, we can see this output voltage. As the time increases, sorry, this is the direction of k. This is not the direction of time. As the duty cycle increases, the output voltage tending to infinite. Okay.
G0. Okay.
So this is the basic principle of step up chopper. Okay. And for the the principle can be applied from the energy, transfer of energy from one voltage source to another. Means here we apply a voltage source here. Here is we are giving a voltage from a supply. This is also a voltage source. Okay. And so,
Okay, ma'am.
so in case of mode 1, when the switch is on, we get this circuit. Okay. Means here the energy is stored in the inductor. Now, when the switch is in off condition, means this is open circuit. So the current is flowing through this. Means here energy is transformed from Vs to E.
Hello.
Hello. So in case of mode 1, the value of Vs is nothing but L di1 dt. From this figure. Okay. So from here we get the value of I1t. Okay.
Okay, ma'am.
As we know, this is a rising current. So di1 dt must be greater than 0 and Vs must be greater than 0. And in case of mode 2, what is Vs? Vs is nothing but L di2 dt plus capital E. And from
Okay,
here,
ma'am.
get the value of I2t. Okay. And similarly, we know that this is a decreasing current from the graph also. This is I2. This is in decreasing in nature. Therefore, we can say that di2 dt is less than 0. Clear?
বুঝতে পারলাম না ম্যাম
এটা
এই জায়গাটা।
ম্যাম এটা এখনো সে প্রিন্সিপাল অফ ডিসি চপার চলছে নাকি ম্যাম?
Step up of DC chopper and the
স্টেপ আপ অফ প্রিন্সিপাল অফ
principle
প্রিন্সিপাল
here
অফ
transfer of energy from a source to another source.
ও ওকে ম্যাম
Okay,
ওকে
as we know that I2 is decreasing in nature. Up to this is clear.
Clear, ma'am.
So we can say that for the stable system, the current must fall and the condition is di2 dt is less than 0. Okay. When di2 dt is less than 0, when Vs must be less than E. This is the condition. Therefore, we can say that from the above, we get that Vs is greater than 0 as di1 dt greater than 0. And from the second case, we get Vs is less than capital E. So, from these two equations, we can say that 0 less than Vs less than capital E. This is the condition for permissible potential of two voltages. Means when there is a chance of transfer of energy from one source to another, this is the condition, necessary condition. Okay. Hello.
হ্যাঁ ম্যাম ওকে
হ্যাঁ ম্যাম বলুন।
Next, we are going to the control strategies. Means how we control the output voltage. Actually, chopper is used for what? For changing the DC, for changing the
ma'am.
DC output voltage. Okay. Means the average output voltage can be controlled to K by by opening and closing the semiconductor switch periodically. And the value of K never be 1 because it cannot continuously open and close. Okay. So it generally lies between 0 and 1. So there are two control strategies. One is time ratio control and another is current limit control. Okay. So at first we discuss the first topic. This is a time ratio control. There are two, in time ratio control, there are two parts. One is constant frequency system and another is variable frequency system. So first we discuss about the constant frequency system. In case of constant frequency system, what happens? Now, the total time period means the total chopping time is same, but we vary that turn on and turn off time. In case of first waveform, we see that the turn on time is nothing but 1/4 of T. Okay, and the turn off time is nothing but 3/4 of T. Therefore, what is the value of K? Okay, the duty cycle sometimes is denoted by alpha in some books. Okay, and K in other books. So I write here that either K or alpha is nothing but 25% because K is nothing but T on by T. Clear?
ওকে ম্যাম
In case of second waveform, we see that we increase the turn on time for the chopper. Means T on is increased and it becomes 3/4 of T and the off time is 1/3 of T. As T is constant, K becomes 75%. So using this principle, we can change the value of K and this is called the pulse width modulation scheme or PWM scheme. Okay, this is also important for your examination. Okay, and next is variable frequency control system. Means here we we take the T-on in both case same, but we vary the time period. As we know that F is nothing but 1 by T, so as we vary T, the frequency is also varied, but T-on is kept constant. So from here the value of K is this is x1. So in the following case, this is not x1. Here in the first two figure, we kept the T on as constant. In first figure, we take that T on is 0, K is equal to 0.25 as it is 1/4 of T. But here this is 3/4 of T. That is here K is equals to 0.75. Okay. And for the next two waveforms, we see that here we take the T of time as constant and we vary the time period. This is the same funda as the previous one. Okay. Then what are the disadvantages of frequency modulation scheme to pulse width modulation? Okay. As the chopping frequency has to be varied over a wide range for control, the output voltage in frequency modulation filter design for such wide frequency variation is quite difficult. And for the frequency variation, there is a possibility of interference with signaling and telephone lines. Okay. And a large off time in the frequency modulation sheet may take the load current discontinuous, which is undesirable because we want a continuous current. Okay. So the PWM technique is better than the frequency modulation technique. Next we go for the current limit control. So in this control strategy, the on and off of the chopper circuit is guided by the previous set value of load current. Depending upon the previous value of load current, the timing of switching chopper circuit on off is based. These two set values are the maximum load current IOMS, which is defined here, and the IO mean. Okay. When the load current reaches the upper limit IOMS, chopper is switched off. Now the load current means when it reaches IO max, then the chopper switch is off. Then it trying to decreasing. And when it falls to the lower limit IO mean, then again the chopper switch is on. This is given from well understood from this figure. When this reaches the maximum IO max, the chopper switch is off and the chopper becomes off. And when it reaches the IO mean, then the current, then the chopper is again on and the output voltage is nothing but VGS. So this is continuous up to when we require the voltage modulation. Okay. And this discussion are written here. Okay. And the current limit control involves a feedback loop. The trigger circuit for the chopper is therefore more complex. So actually the PWM technique, pulse width modulation technique, is more commonly used for the control strategy for the power control in chopper circuit. Okay. So today we have learned the step, what is the chopper, what is DC chopper, what is the advantages of DC chopper, what are the application, then step down principle of step down chopper, working principle of step up chopper, and the control strategy. And the next class we discuss the leftover things for the chopper circuit. Okay, and I will inform you through WhatsApp when the next class will be happen. Okay.
Okay, ma'am.
ঠিক আছে
Okay, ma'am.
Okay, ma'am.
Okay, thank you.
Okay, ma'am.
Okay, ma'am. Thank you.
Thank you, ma'am.
Thank you, ma'am.
Thank you, ma'am.
Ma'am, can you share the note?
Yes, yes, in the YouTube. Okay.
ठीक है ma'am.
Okay.
Okay.
Thank you, ma'am.